So, good morning, everybody, on this very grey and rainy day in London, very London weather. Hopefully you're all awake and had your coffee. Expecting questions at the end. So I'm going to walk you through this journey we've been on. I'm this head of this very long-winded named group at Credit Suisse. We go by SAMI for short. For those who don't know Credit Suisse, we're a global investment bank. We are in about 50 countries and we have about 46,000 employees. It's a very large, old enterprise, been around for a long time. So the areas I cover for Credit Suisse are semantic technology, which is around ontologies, network data, how the new world of data looks, the big data compute platform, we use a Hadoop Cloudera stack, machine learning, artificial intelligence, and e-com surveillance. So what we're focusing on today is actually on the AI e-com surveillance piece of it. And I'm going to do my best to represent my AI e-com team. I am not the data scientist in the room, but I'm going to do my best to represent. So my e-com surveillance team is based in London. Oh, there we go, picture of London. They have skills and specialist skills in both natural language processing and unstructured data, which is very key, especially in the e-com world. And they like to think of themselves, and they are a pack that likes to walk forward and try and explore the unknown. So they're constantly looking for new challenges and new ways to address problems. That in itself can be challenging to make sure that you have the business case to back that up and you're actually delivering on a mission, when you have very bright people who always want to constantly try new technologies. So the team motto is empower the art of the impossible, but focusing on making it possible. A little different from the Microsoft motto. So I'll start with the problem we were trying to solve and why e-com surveillance is so difficult. So I'll cover that up front. I'll then introduce the surveillance pipeline and show how we've used innovation to transform surveillance and make it more intelligent. All these solutions I'm going to show you today are actually in production. This is not POC, this is not dream pipeline, they're actually real. And then lastly, I'm going to go through kind of the sense of success. What were the lessons we learned? How did we benchmark? How did we measure? And I'll, of course, take some Q&A at the end. So why do we do surveillance? Well, I think obviously you want to protect the bank, right? Both from a regulatory perspective and a financial perspective. You see the press, you see the news, you see the fines that come down on banks that get this wrong or fail to spot somebody who's a potential bad actor. So that's the problem you're trying to solve, to meet the regulatory requirements. And there's two main reasons why e-com surveillance is so difficult. One is the person, Mr. Bad Actor over here, and the second is the data. So let's look at the person first, right? So he doesn't look like that. If he looked like that, that would be really easy, right? You'd be able to walk into a room and go, oh, there you go, bye. No, he looks like everybody else. So when somebody comes along and decides to be deliberately malicious, right, you've got to find them. They're not always going to be sending malicious communications. They're not always going to have something untoward in what they're saying. They could have a secret language they're using with their co-conspirators, right? It could be pizza. Right? One day they want to put ham on it and the next day salami. That could have a whole different meaning. So what you have to look at is difference in patterns and behavior across communications through time. And that's when you're looking at over 1 million emails or e-com ingestion a day, about 1,000 per person. It's a lot of data that you have to sift through. So then we get to the data, right? We've got chaotic, unstructured data, right? Gartner reckons that about 80% of the data within an enterprise is unstructured, and that's growing by about 62% a year. That's a lot of unstructured data, and it's just getting worse and worse and worse. And that's just within the enterprise. That doesn't factor in social media, other information you might want to bring in. It's a big world, right? All the e-coms data we deal with is unstructured. And if you think about the types of data, when you're writing emails, you tend to be more formal in your communication style. You could be using different languages, different context. You'll have documents embedded, images. And then you move on to chat, more informal, shorter sentences, code words, keywords, emojis to explain meaning, right? Whole different ballgame. And then you get to chat rooms. So how do you look at the behavior in chat rooms when people are moving from one room to the next, jumping, and then sitting on someone else's room and not saying anything, just being an observer? Does that mean complicity? All very open questions in surveillance. That variety of data and the sheer volume really does make it finding a needle in a haystack. So what do we need to do to identify these potential bad actors and stop them? So that shield in the middle is the people, right? So by enabling the people to do the job, the surveillance experts to do the job that they are hired an expert to do, we have to bring technology to bear. We have to enable that surveillance person to protect and to act as that shield. We do this by processing the data at scale, so they don't have to. We add the intelligence so that they can actually look at things in a very smart way. They don't have to go through the old world of reams of paper trying to figure out who the person is in the first place, right? We created a machine that essentially thinks and learns like a human being and helps the human shield actually do their job properly. And that's what I'm going to walk through today. So let's start off with the surveillance pipeline. Okay. Now, e-com surveillance is a big data complex problem, right? You've got the variety, you've got the volume, you've got the velocity of data that's coming through. So what we're doing is starting with the people on the left that we need to monitor with the ultimate goal of identifying Mr. Bad Actor there over on the, actually, have I got that the wrong way around? No, right. Now, how do you get there? Well, first, we adjust all the email communication, e-com communication, chat, phone logs, everything, right, goes into the pipe. And we hit our first problem. I'm not just one person at Credit Suisse. I have up to 15 different identifiers. I have my email, my employee ID, my Bloomberg email, my chat handle. I have all sorts of different ways to describe me. So the first thing you have to do is resolve the entity, right? The entity resolution problem. And that's, we do it for employee, for e-com, but this applies just as well to clients, to product, to everything that's out there. And it's not an easy problem to solve. So that's the first bit. It's an industry-wide problem as well. So that's a layer that we added, right, was the entity resolution layer. That way you don't have to look at 15 different versions of me and try and determine whether it's me. You're just looking at me and all my communications around me. From there, we start generating these alerts. And I'm going to dive into each of these a little bit deeper so you get more of a context. So these alerts are a lexicon-based alert. So what does that mean? It's like a dictionary. You say, basically go to FX and you say, what are the words you think people would use in their email communications if they're trying to, if they're up to no good? And then if that word shows up, you raise an alert. Now you can imagine the pure volume of false positives that generates. Think about the word fix, right? I could be fixing my bag, fixing lunch, fixing a trade, right? But in an alert system, it's all going to pop up and somebody, that shield, has to go and trawl through all that information that comes back. That doesn't make people very efficient. And it also means you can imagine, the millionth one you've gone through, your brain's probably at the point where you're not really seeing the words anymore either, right? So it's pretty key to be able to bring that down. So what we did here was we introduced an intelligent filtering layer, right? And that's where we applied deep learning. So we used natural language processing and supervised learning with GPUs to add this layer in there with deep neural networks to help add that intelligence filter, to tell them which communications they should really focus on, which are the high probability ones, that there is something really going on. And then we've got a forensic piece, right? We also needed a tool where you could go through and say, okay, I've identified something. Now, how do I actually know what the impact of that was, right? If I sent that email to you, you forwarded it over to you, you forwarded it to 50 people over there, how do I see that graph, right? How do I see that network? How do I know who's actually involved or now knows about it, sometimes unwittingly? And that's what we do in the forensics tool we've created. It's the semantic tool, so it uses semantics, and it uses graph technology. So it's highly visual. And you can drill into any persona, communication, keyword, whatever it might be, and return the information back that you need. So this didn't happen overnight, right? This took 5 years of research and development and engineering, end to end. And there were lots of steps across the way. So I'm going to dive a little deeper now into the surveillance toolkit. So that entity resolution piece we call Artemis. we come up with very creative names. Well, my team in London comes up with very creative names. I think it started life being called Pinkie Pie, so Artemis is a lot better. So that resolution bit there was built on open source technology. The other piece about this landscape is when you look across at what's out there in terms of vendor product, there's no magic bullet, and we find this with a lot of problems we have to face down that the business brings to us. There's no one single magic bullet you can go out there and buy that's going to solve all your problems. You usually have to take a layered approach. And quite often that means buying a product where it's fit for purpose for that thing, and then adding the intelligence or the bits on the side of it that are going to make it more meaningful. So Artemis we built with open source, and we were able to produce this entity resolution engine. Obviously, engineering cost only, really, and data science, so no vendor cost in there. Then we get into, so that brings us to the canonical view of a person, that's a single view. We mapped all the communications to the right person, but also more importantly, this temporal view. So I could be Sarah Gadd today, but if I was using my married name, I'd be Sarah Martini. Yeah, don't ask, it's a much better last name, but I just couldn't go there. But my identity may change through time. I may change my email address. It may get hacked, and I decide I want a new email address. When I'm looking back historically from a regulatory investigation perspective, I need to see me through all time. I can't just see me from when I had changed my name. So that temporal aspect to it is actually very key. So we're looking at here as the time to insight diagram. So if you think about the way surveillance was done back about, I don't know, about 10 years ago, it was reams of paper. They literally used to have to do sampling and read reams and reams of paper. Extremely time-consuming, very, very difficult to identify bad actors. So by introducing Artemis just on an entity resolution basis, you're already bringing down both that volume of noise, that chaos, and the time to be able to surveil. The next piece is the deep learning intelligence piece, which we call Talos. So Talos is that intelligence filter that we've put there. So how does that work, right? So we've got these alerts that have been raised on the lexicon basis. So it's found the word fix, right? Thousands and thousands and thousands of alerts. 99.9% of them are all going to be false positives. You know that up front, but you've got to identify them. So you have to bring context in. So you feed these potentially malicious ecom, these alerts, into an engine. The first phase, you're parsing. So what you're doing is stopping and stemming of words. You're taking the I am fixing the market, if only life was that simple, let's take that as an example, and you're removing all the words which are superfluous, and also then stemming words back to their base. So you end up with fixed market. The next is the vectorization phase. So you're going back to the meanings of the word. Now you can't run algos on language. Very hard, right? You have to do it on numerics. So what we're doing here is we're converting the words to a numerical value, and that's based on their position and adjacency to other words. We use things like Gigapedia, stuff you can go out and get, to train the machine to understand how to assign numerical value during that vectorization phase. And now we have the algo, the kind of magic piece, right? That uses a deep neural network. And what that is now doing is it's using that feedback loop from the supervisors, from the human shields, where they've gone through the electronic communications and said, that alert is a false positive, that one is worth reviewing. It's taking all that in on a constant basis, and it's training that machine to understand the context of the words in the communication. So now that you can start to flag which ones are actually really worth reviewing, and what you should look at first versus the stuff which is a very, very high probability, and we have a very high threshold, over 90%, that it's nothing, right? So the architecture around that intelligent filtering bit, and I promise you it's the only architectural type diagram I have in here. We start with GPUs, I'll explain why in a minute. We put CUDA on top of that. So CUDA is your API between the application and the GPU engine. Kublas, which is on top of that, is a matrix representation of the data that is sitting there. Python is the code we use. As a programming language, we use Python to actually code up this algo. And then we use TensorFlow and Tiano as a kind of implement the mathematical functions that take place as part of the algo. There's a lot of libraries of methods and functions, and it simplifies the coding language you need to do. Then Keras, that sits on top of that, abstracts the library specifics, and it bridges across the libraries like TensorFlow and Tiano. And then we have the magic algo that sits on top. So now when we introduce Talos, you can see the dramatic reduction in both the chaos and the time. So that's where that's kind of the sweet spot, right? Now I would say we get to the glazing on the top, right? So how do you provide the interface so that, first of all, you can catch that feedback loop, right? You have to get the information back from the supervisors. You have to know what they're marking as worth reviewing and what is a false positive to be able to teach the machine and carry on with the learning. I'm going to pause there just for a second. Does everybody know what the difference is between kind of machine learning and deep learning? I know they're words that kind of bandied around. So the way that I put it, which usually helps people get their head around it, is if you think about the kind of driverless car, right? With all the news in the press lately, probably not something you want to be buying right now, but if you think about that, you can teach the car through machine learning that if it sees a shape, it's got these many sides, it's red, it's got these words on it, it's a stop sign. And that's great. But if it's a foggy day, or there's a tree branch in front of it, or it's obscured, it's very difficult for that machine to then recognize a stop sign. What deep learning does allows you to run thousands and millions of very simple parallelized computations side by side, very, very fast. So you can put millions of images of stop signs through the machine to teach the car to read a stop sign no matter what the conditions. And that's your neural network piece. So that's your kind of deep learning versus machine learning in a very kind of high level, non-data science way. Right. So the review is a dashboard piece. That's where people go to review the alerts. That's where we capture that feedback loop and put it back to the machine so it carries on learning. And then the forensic piece, so that again, doesn't really do much about the noise, but certainly helps with the time because it's a centralized place, visual place people can go to go see these alerts. They're not trawling around trying to find them. And then the forensics piece is where you need to go do further investigation. So this is this graphical-based interface. So it's if you think about, I don't know if you've seen these graphs on Facebook. You know, the internet is the semantic web, right? It's the reason when you type a search term into Google, you get results back because the data's networked together. It's a giant graph that sits behind all this stuff, right? So it's not just this is a country, it's the relationship between the country and the region, right? Sarah is an employee, but I'm friends with, employed by, report to, right? These are all relationships. It's a very agile model as well, so you don't have to go and re-engineer the existing data models you have. You can put this right on top of them. So it enables you to go further and then produce these graphical interfaces. So that's the dynamic visualization of the communication networks we developed. Also helps you identify the good actors as well as the potential bad actors, so you can get rid of the people who are actually behaving in a very good fashion. And that's Cypher. So forensics allow you to really drill in very, very quickly and dynamically in real time to any investigation you want to do. You can literally respond instantaneously to any question you get around a communication that takes place within the bank. So that is the surveillance pipeline. Okay, so what was the kind of sense of success and how did we measure this? You know, when you're embarking on a journey, you have to be able to show progress along the way. And quite often it is a journey, right? You start with one thing. We started with lexicon, we implemented that. Business came back and it was like, whoa, the amount of noise we're getting, it's a lot better than what we were doing manually, but the amount of noise we're getting is the same. Can you do something about that? So you embark on this journey. Initially, when we wanted to reduce the noise, we targeted about 12.5% reduction. That was the business target. The team target was around 30. We tried first, standard lexicon, which is that dictionary type lookup, then went through a variety of quantum machine learning approaches. We were able to reduce the noise 13%, which was better than the business target, but we thought we could do better than that, and we had a really good partnership with the business team. So they supported that, and that's when we introduced deep learning. So we got the noise factor down by 37%, and that was straight off, right? So as it learns, it improves, it gets better and better and better. So measuring this and being able to provide these benchmarks back to the business is key, because it's something they can understand. Right? They don't have to understand the technology, they can understand the improvement, and you can show the improvement. The other thing you need to be able to do is accuracy, right? So heuristic is that lexicon-based approach. It's a dictionary approach. You know, it doesn't give you a very high level of accuracy. When you start doing generic machine learning libraries, you improve the accuracy, but when you introduce deep learning, and you've got the IP from Credit Suisse, so you've got the SME expertise coming in, you're not buying something off the internet, you're not downloading open source. You have that SME overlay that you're bringing in, and all of a sudden your accuracy goes through the roof. That's why it's very difficult for companies to come up with canned deep learning type products, because it's all about the data. That's the 300-pound gorilla in any room, right? You've got to get the data right, and it has to learn off your data. You know, most enterprise data, it's not cookie cutter, right? It's all going to be a little different. We're all going to store things in slightly different ways. So it has to use it and take that in. And that's, bringing that knowledge in is what really improves your accuracy rates. Why GPUs? So GPUs are your graphic processing units. It's basically what sits in a lot of your gaming boxes, if any of you are gamers, right? When we started running this on CPUs, because they're quite complex calculations, but they can be parallelized very easily, the CPUs couldn't cope with that, and it was taking 2,250 minutes to run an execution. Really long time, not very efficient. So we decided, because of the nature of it, if you can parallelize the calculation, it works really well with GPUs. GPUs aren't great for everything, but for parallel computations, they're great. And by using a single GPU, only one, we brought the time down 150 times to 15 minutes per execution. So it's a great, there's a lot of places that are looking at GPUs in quant, right, and algo trading, where there's been a lot of models that have been run traditionally, and using that is, I think, is pretty key. So what are the key learnings? I'm going to cover these in a sec, very quickly. So unicorns are rare, right? So when you're looking at having a task force focusing on a problem, it's not just the data science. My team comprises of engineers, people who understand semantics. They may have degrees in philosophy and literature. And then it's the deep data scientists. You have to bring these skills together to be successful. And cross-train is great SME expertise. In a lot of our institutions, we have to upskill them on the tech. So by having these partnerships to remove the fear from people who work on mainframe, etc., really helps them progress. Enterprise is tough. Be patient, be tenacious. You know, the legacy infrastructure, it can be very hard to navigate. Choose your passengers carefully. Make sure your business is backing whatever you're trying to do and keep them updated along that journey. If you're going to fail, fail fast, learn from it, move on. Don't hold on to something that's flogging a dead horse, right? Explore without fear. You have to be able to try new stuff, right? You have to be able to do that and then fail. You've got to be able to push the boundaries, otherwise you're not going to be able to innovate. And as I said before, don't look for the magic product. I see so many businesses waste literally a year trying to find the magic product that's going to do everything for them versus understanding the components that they need to deliver on. Because there's a lot of great product in the market, especially from the fintech community, that works really well in a certain area. Use it in that area, right? You know, it's an agile technology era we've entered here, so use it as such. And that's it. I will open up to Q&A.
Please, anyone who has questions, maybe we can get a mic to circulate.
Any questions?
Anyone from the audience?
Or are you all still waking up?
Just a couple here.
Hello. Hi, Marcus Martinez from BCS Consulting. Is that applicable to data from social media? So when you look outside the organization, so data from Twitter, Facebook.
Yeah, absolutely. I mean, that's, you know, semantics especially play a huge role there. So there's a lot, because the web's been around for a long time, and as I said, it's a semantic web, there are standards in place that a lot of the social media companies have actually adopted in how they describe their data. And by utilizing those semantic data models, you can actually pull in social media data much easier than you could do if you were trying to model it when it came in the building. Right? So absolutely, a semantic approach really is the only way to deal with the big wide world of data, IoT, all that. It's the only way to cope with it, right? You can imagine trying to apply traditional data models to the Internet of Things, right?
Good morning, Brendan Gilmore, BPG. I'm just wondering, are there any practical examples or tangible examples of what that's led to? Because that's great, it looks wonderful, but I'm just wondering what it led to in terms of people that sort of were the bad actors you found and what happened.
I definitely cannot go into that.
So I don't mean name names. It's just really like, has it led to...
No, I know. I mean, what I can say to you is that the team, from the surveillance perspective that we're focusing, so there used to be literally nearly 100 people who were having to focus on doing surveillance, right? And they weren't really doing surveillance. They were just trawling through reams and reams and reams of information, trying to understand the landscape. Now it's a very small team. So from an efficiency perspective, it's certainly helped because they can now do their job, right?
Hi there, David Holmes from Penn Partnership. So I'd be interested to know how you keep up to date with the changing nature of language. So obviously the way we communicate changes over time, and obviously the machines don't. So how do you manage that challenge?
That's a challenge we're currently working on right now, right? So one of the things that we need to tie down, and is the next mission from the business, is that in communications, quite often people will change context and language within the communication. So they're not using, Greek and English, they're using a mixture. They're using like a pidgin, right? And to be able to identify that halfway through or as the context of the information is challenging. There's nothing out there that does it. So first of all, we hire very smart people, usually from straight out of university, from places like UCL, where they've done some kind of work in the space or played around with it. And that's the people we put to bear on that specific problem. They partner as that task force with the engineering team so they can understand how you commoditize that and what you're going to need to make that real. But it's something we're currently working on right now. Our guys are very interested in it.
Hi, Abdullah Mashal from BCS Consulting. It's amazing listening to the sort of suite of products that you've built. Are there any plans for this to be, if you like, spun off and made available to the market, given how much, if you like, effort's been put into it? And also, 10 years down the line, do you still see this, if you like, investing time and effort on an ongoing basis, and whether that draws away from your core banking reason for being?
Yeah, no, it's a good question. So, I mean, we have thought about, we build stuff. My group sits in the middle of Credit Suisse, right? So we work with all the divisions at Credit Suisse. So anything we create in a commoditized way. So it can be used by the different divisions and theoretically could be spun off. The challenge is, as I mentioned earlier, right, even if you spun it off, you would have to go through that training bit. And we have training tools as part of the toolkit that have with the machine learning training. So we've talked about it at a high level. We put this into production, the last piece of the puzzle into production at the end of last year, so it's still kind of early days.
We have time for one more question.
Well, thank you all very much for your time. I hope you enjoy the rest of the day. It looks like it's going to be a great session.
Thank you.